Hi students in Math 241. Since several of you aren't able to come to our class, I wanted to share a couple of insights that we talked about when we were in class today. The first one has to do with the first assignment, constructing triangles. And what I wanted to highlight is actually that they ask you to construct three. They ask you to construct just a general triangle, and then an isosceles, and then an equilateral. And it may seem funny to you to draw just a plain triangle, but the point I think that they're trying to get at here, which is really good, which is that you want to be able to compare the different types of triangles. So here's my sketchpad document here. Let me just, there we go. And so to make the first triangle, you can just use the segment tool and hold down, and you notice how you can connect segments by having the lines go right over each other and then the vertices line up. Now what you notice here is that this triangle is not a specific triangle. It can be a right triangle, it can be an isosceles triangle, but it is the most general case of a triangle because it's really built with just three sides that connect. You can also run into questions like, is this a triangle? Is this a triangle? Is this a triangle? And one of the interesting things is that little children, when they are first shown pictures of triangles, they're almost always either perfect right triangles or perfect isosceles triangles. So if you ask a child, you know, is this a triangle? They'll say yes. But as you move it down, they begin to question, well, is it still a triangle? Is it still a triangle? There's one famous video of where a student actually thought that this was a triangle because it was simply lying in a different plane. So kids come up with amazing insights. So that's the reason that they have you draw this triangle first, and then they have you draw the isosceles triangle. And they do that by actually having you put segments that are radii of the circle. So now you know that this is an isosceles triangle, and you can actually type that in and say, you know, I know this is isosceles because two of the sides are radii of the same, circle. So what you can see here is that we're able to draw and also write, which is really, really important. Now let's do the equilateral triangle. In this case, you can start off with a segment, and then you're going to draw two circles, one centered at the one end point, and the second centered at the other endpoint. And now what we know is that these two circles actually have the same radius, hence they're called congruent, right? But now we know that this point here is the intersection of all of the points that are the same distance from this point and the same distance from this point. So when I select all three and say construct segments, I now have an isosceles triangle. And you can notice that when I pull any one of these, well, actually, when I pull the independent point on this triangle, right, this point doesn't move because it's independent, but this one does. Conversely, if I move this one, these 2 points move because they're both dependent on this. On the other hand, if I move this, okay, notice that this point is already dependent, and so the independent point doesn't move. So in this case, 2 points stay static, right? Here, these 2 points move, and here, those 2 points stay the same because they're all three independent. So that's the main point of the first activity. We also talked about the second activity. In this case, one of the things that you're asked to do is to go to Sample Sketches and Tools, click on Geometry, and then click on the Properties of Shapes. Now what you see here is that, especially in the quadrilaterals, you notice that all the shapes look about the same. However, once you start moving them, you can, and I'm just going to make them smaller here, you can sort of start to play around with the idea of, well, let's take a look at this yellow guy first here. Okay, so we're going to move it around and we're going to see, well, maybe it's not a square. because although if I move this, it appears to stay a square, and if I move this one, it appears to be a square. But if I move this one, we can see that it's actually probably a rectangle. So let's put that as our hypothesis. Now let's use the information tool and see if we can figure out whether it's a rectangle. Well, we know if it's a rectangle, we know that these two lines have to be parallel and these two lines have to be parallel. So GH connects G and F. I'm sorry, G and H. So H is an independent object. Oops. And here's point G. Those are both independent objects. So let's see what this one is. Okay? This is the intersection of this perpendicular line and this one. So if we have the intersection of two perpendicular lines, then we can be assured that this is a right angle, and we know that these two lines are parallel because they're both perpendicular to this one, and we also know that these two lines are parallel. So using the definition that we had from day one, we know that we have two sets of parallel opposite sides that are parallel. So therefore, we can write this is a parallelogram, because, and this is something that's really cool, is you can actually click, once you're in this A tool, click on the side. So you can say, okay, FH, and then we're going to use this to show the congruence tool. So I'm going to have to make this bigger for a second. Okay, there's the congruent tool. Excuse me, we want to say parallel though, don't we? So you're going to pull down this little arrow here and say parallel. And by the same token, HG, once again, is parallel to AF. Because both sets of segments are perpendicular to the same set segments. Okay, now let's look at this one now. This one here looks to be a trapezoid. What do we know about a trapezoid? Well, it actually has several different definitions, but the one that we probably want to look at most is that it has at least one set of parallel lines. So it looks to me like this line, and we can also go like this and just click on to get the letters there. It looks like MN is parallel to PO. So basically, the directions just say that you can just identify that. So it would be sufficient to say it appears that MN is parallel to PO, and so since we have one set of parallel sides, it's a quadrilateral. With one set of parallel sides, then it must be a trapezoid. We can go further, again, use the information tool and see if we can figure out why those are parallel. So let's look at point M. Well, that's perpendicular to line 22. Well, let's look at point O. Point O is an independent object, and P is an independent object. So what about this one? Aha. So this segment here, PO, connects point P, which is an independent object, and point O, which is an independent object. So the question is, how do they make these two lines parallel? Well, the answer lies right here in N, because it's on ray 23. Well, what do we know about ray 23? It passes from M through point number 2, which is hidden. Well, point number 2 is a vector translation of this. So if we say that P to M is going to be a vector, then we translate O to this point here, and what we find out is that, in fact, this is just point number 2. Since these are parallel, translations preserve both distance and direction. So therefore, these two lines must be parallel. And therefore, since this is perpendicular to this line, these two lines must be parallel. So, in fact, since this is an independent point, we know that both MN and PO are perpendicular to PM. And therefore, that's why this is a trapezoid. So that's the second part, and I'd like you to actually try to write a little bit more of an explanation than simply just labeling it as the directions say. So good luck. Hope that these two comments were helpful.